Right, so I've set up a little example here. I've stuck with y equals x for the first part of the graph, where I've developed this question. Have a look. It says if a vehicle is increasing its speed from standstill to 15 meters per second in 15 seconds, then stays at 15 meters per second for 20 seconds, then returns to rest in 30 seconds. Calculate the total distance travelled by the vehicle. The velocity time graph would look as shown below, and I've drawn the graph there for us. So what we've actually got here is section 1, section 2, and section 3. And we can split them up like that. Now we already know that for section 1, y is equal to x, and we know that the acceleration is equal to 1 meter per second squared, and the distance that's travelled was 112.5 meters. So we got that one covered. Now look at the next section, section 2. In section 2, y is equal to 15 for the whole section. And in section 3, y is equal to, now you ready for this, 1 over 2 x plus 15. There you go, 1 over 2, actually it's negative 1 over 2 times x plus 15. So there's our three functions. We've done section 1. Section 2, let's integrate first. So if we do the integral of 15 with respect to x from 0 to 20. Now I'm doing 0 to 20 rather than 15 to 35 because the graph is only consistent between 15 and 35, which is a range of 20 seconds. Now we integrate 15. What we get, because this is essentially 15 x to the power of 0. So we do the same thing we did before with the x. So we're going to add, change my pen color. We're going to add 1 to the 0, and then we're going to divide by 0 plus 1. So essentially what this becomes is 15 x to the power of 1. So essentially 15 times x. Now if we put this in an equation, we have 15, let's put it in square brackets, x minus 15 x with limits of 0 and 20. If we put 0 and 20 into our formula, we get 15 times 20 minus 15 times 0. So this is equal to 300 meters. That's the distance we're going to travel in section 2. Now we're going to differentiate 15 and see what our rate of change on the line is. Now you can see already that there's no change in that line. So what happens then if we put it into this formula? Now in this case, y is just equal to 15. So 15, when we differentiate it, becomes 0. So the acceleration equals 0 meters per second squared. So there we go. Because there's no x, it has to become 0. In section 2, our acceleration is equal to 0 meters per second squared, and our distance is equal to 300 meters. Finally, we've got section 3. Now section 3's got a bit more of a complicated equation, but we're going to keep it simple. Let's integrate first. Well, an integral. Now remember before, we have to start at 0 and go to the length of the line. So we've got 0 to 30. We've got 1 over 2, or negative 1 over 2 x plus 15 dx. So now if we integrate this the way we did before, this becomes 1 over 2, or negative 1 over 2 x. Now it's x to the power of 1, so it will become x to the power of 2 over 2 plus Now 15 hasn't got an x value, but it is x to the power of 0. So 0 plus 1 becomes 1, and then it will be divided by 1, so we can leave that off. So there is our integrated equation for section 3. Now if we put it into the formula the way we need to, we've got 1 over 2 x squared over 2 plus, that's times there, plus 15 x, right? Now it's minus 1 over 2, or it's minus 1 over 2, so it becomes plus 1 over 2 x squared over 2 times there plus 15 x, and our limits are 0 and 30. So as you can see, this second half of the formula, since x is 0, we've got half times 0 squared over 2 plus 15 times 0. So this is just going to cancel off, and we're left with this side. So if we write that side of the formula out, we get 1 over 2, negative 1 over 2, 30 squared over 2 times there, plus 15 times 30. And that will equal, let's have a look at the calculator, 225 meters. Our acceleration, so we got d by dx, sorry about me d's, 1 over 2, negative 1 over 2, x to the power of 1, isn't it, plus 15. Now the 15 is going to cancel off, and this we're going to do 1 minus 1 up here, and we're going to bring the 1 down in front, so 1's not actually going to affect it. What we're actually going to get is negative 1 over 2 x to the power of 0, and this x to the power of 0 is equal to 1, which again cancels off, so our deceleration is equal to negative 0.5 meters per second squared. So then acceleration for section 3 is equal to negative 0.5 meters per second squared, and the distance travelled is 225 meters. So these are some basic rules. Now obviously functions get a lot more complex than an x, so we have some extra rules to help us out. We've got the chain for differentiation, we've got the chain rule, the product rule, the quotient rule, and then we have logarithmic differentiation. And for integration, we have integration by parts, integration by substitution, and integration of partial fractions. Now these rules as an engineer are something that you don't really need to know that well, because most of the time we can use a program to do these things for us. But it's worth knowing that they exist, and it's worthwhile going online and having a look at some examples of how to do each one of them, so that you know and won't be caught out when you are stuck without a calculator or a computer program. Also, there's certain functions that have special values in them, like like sin x. If we differentiate sin x, it becomes cos x. If we integrate cos x, it becomes sin x. And you'll notice there we got plus c on our integrations. Generally, every single integration you ever do will always have a constant of integration, that plus c. It's kind of a formality to throw it on there. Sometimes it affects the equation, sometimes it doesn't. Lower down we've got e to the x. If we differentiate, that's the exponential to the power of x, the x-axis. That will become e to the x, it stays the same. The same when we integrate e to the x, it also stays e to the x, but we have our additional constant of integration. Now these are all the rules. This is for extra reading. Other than that, that is calculus. So have a go at that on some more complex functions. So there's one final thing I want to show you. This is how we use a calculator. Now you'll notice on the left hand side of the screen there is an application open. Now this is something free one you can get on Android. If you notice there, next to where it says calc, there's an integral, and the shift version is a differential. Now I'm going to show you how we can input the 3 formulas that we've worked out and find the exact same answers just by putting in the formula. So watch section 1. if I do the integral first, and our limits, if you remember, were 0 to 15, that's our limits on the x-axis. And in there, if we press alpha, and there's the closed bracket, above that is x, put that in there. From 0 to 15, if we press SD, we get 112.5, which is exactly the same as we worked out for our distance. And on section 2, we got limits of 0 and 20. And our equation for the line was 15. So we got 300 meters for that one. Exactly the same as we worked out before. And if we change the 15, now we need to have 20, needs to be limits of 30 for section 3. Then we got negative 1 over 2 alpha x plus 15. And there we have it, 225 meters for section 3. And that's just inputting the formula to a basic integral equation. Now if we clear that, we'll have a look at differential. Now we need to do shift and the integral formula now. Our first section, we're just looking to integrate x. Now it wants to know at what time we want to know what x is. Now it doesn't matter in this case. If we put in 15 and we get a gradient of 1, now we could put any value in there. Look, 1 gives us a gradient of 1, 8 gives us a gradient of 1. Section 2, and we had 15 in there, and it doesn't matter what x is. X can be any value we like, it's always going to come out as 0 because it's 15, it's constant, there is no change in that line. Let's have a look at the next bit. If we put our formula in, negative 1 over 2, come on, alpha x plus 15. Now it's just that 15 doesn't matter, nor does it matter what value we put on x. Why? Because it's a constant gradient. If we put 61, sorry, still negative 0.5. So there we go, that's how we can use a basic and free application to be able to work these all out.